Have you ever sat down to tackle a research project, stared at a blinking cursor on a blank screen, and just felt completely stuck, like totally overwhelmed by where to even begin? Well, if that sounds familiar, you are definitely not alone. You're probably suffering from what researchers actually call problem blindness. It's that, incredibly frustrating, kind of paralyzing feeling when the universe of unexplored questions is just so vast you literally can't find a clear starting point. But hey, don't worry, there's absolutely a cure for it.
Welcome to This Explainer. I'm super excited to guide you through this because today we are completely demystifying the research process. We're going to take a journey together, moving from that broad, foggy confusion of a vague idea all the way down to pinpoint academic accuracy. By the end of our time today, you'll know exactly how to turn just a passing thought into a rigorous, totally verifiable scientific study. Let's dive in.
Here's our roadmap for today. First up, we'll cure that problem blindness. Second, we're going to formulate your actual research problem. Third, we'll translate that problem into smart objectives. And finally, we'll test propositions and hypotheses.
All right, let's jump right into section 1, curing your problem blindness and finding your direction.
Nailing down the exact problem you want to solve is absolutely the most crucial and, ironically, the most difficult step in the whole research procedure. So what is problem blindness exactly? Well, it's basically that initial phase where a research problem just seems way too vague or unclear. And honestly, if you don't cure this early on, your entire research process is going to lack direction. But listen, it's a completely natural hurdle. It usually just comes from, say, insufficient knowledge about your specific field, or maybe just a bit of a lack of preparedness. But I promise you, it's highly curable once you know what to look for.
See, identifying a research problem isn't some mechanical, robotic process. You can't just plug a formula into a calculator. Finding a really valid problem requires you to be actively hunting. It takes patience for sure, and a lot of insightful thinking. You really have to dive deep into the existing literature of your specific domain and actively look for the gaps. The areas that haven't quite been adequately explored yet. Because those gaps, that is exactly where your research problem lives. Now, there is a stark contrast between a poorly defined problem and a well-defined one. Take a look at this. Asking how to improve sales? Well, that's incredibly vague, right? It gives you absolutely zero direction. But asking what marketing strategies increase sales of product X in market Y? Now that is beautifully specific. A well-defined problem like that instantly gives your research a clear design. It tells you exactly what methodology to use, and it even helps you determine your sample size. It is literally the foundation for everything that follows.
Okay, moving on to section 2, formulating the research problem, where we build the foundation.
So once you spot that gap in the literature, how do you actually construct it into a formal problem? Well, here's your blueprint. Problem formulation really boils down to two main things: understanding the problem deeply, and then converting it into analytical terms. We've got 4 pillars here. First, the definition of the problem. Second, the statement of the problem. Third, the evaluation of the problem. And fourth, the operationalization of variables. Now that last one sounds like a mouthful, but it simply means taking a broad concept, like say, effectiveness, and defining exactly how you're going to measure it out there in the real world.
But hold on, before you completely lock in your problem, you really need to evaluate it. Practically speaking, this means accumulating facts and finding associations. You need to question your own underlying assumptions. But honestly, the most important thing you need to ask yourself is this problem workable for you? I mean, you might have found the most fascinating problem in the world, but do you have the specific expertise to analyze the data? Do you have the budget for it? Do you actually have the time before your deadline creeps up on you? A great research problem might be super interesting, but it absolutely must be feasible within your own specific constraints.
That brings us to section 3, crafting smart research objectives, so we can start setting some clear goals.
All right, so our well-defined problem is now ready to generate some specific goals. Think of research objectives as the direct roadmap derived from your initial research problem. If the problem is your final destination, the objectives, they're your turn-by-turn directions. They provide a clear, concise description of exactly what you aim to achieve by actually conducting the study. They guide your entire research process, making sure you stay perfectly on track.
Now, to make sure your objectives are perfectly calibrated, you should really always use the SMART criteria. Specific means there's just no room for confusion. Keep it narrow. Measurable means you've got actual metrics to track your progress. Achievable reminds us once again to be realistic about our resources and our budget. Relevant ensures the objective actually links back to your main research problem. And time-bound? That just means you're setting strict deadlines for yourself to keep the momentum going. If your objectives check all 5 of these boxes, trust me, you're in incredible shape.
Let's wrap things up with Section 4, testing propositions and hypotheses, moving from theory to data.
The absolutely crucial point right now is figuring out how to bridge the gap between theoretical ideas and actual testable data. Let's start with what we call a proposition. A proposition is a tentative, hypothetical relationship between theoretical constructs. It's usually just stated as a declarative sentence. For example, an increase in hard work causes an increase in academic performance. Now that sounds great, right? And it might be based on excellent logic. But notice something super important here. It lives purely on the theoretical plane. You literally cannot directly measure hard work or academic performance as they're written right there. They're just way too abstract.
And right here is the aha moment, when a proposition can actually be examined for its validity through empirical investigation. It becomes a hypothesis. We have to take those theoretical constructs and convert them into operational measures. So our abstract idea of hard work becomes a measurable thing, like study hours. Our abstract academic performance becomes a measurable grade point average. So now we have a solid hypothesis. An increase in study hours causes an increase in grade point average. Boom! This is now empirically verifiable using collected data.
To make it work, a scientific hypothesis really must clearly specify its variables. We've got the independent variable, that's the cause, the thing we either manipulate or observe changing, which in this case is the study hours. Then we have the dependent variable, that's the effect, the characteristic we're actually measuring to see if a change occurred, which here is the academic performance or GPA. Keeping these two completely distinct is absolutely the core of testing your theories.
To kind of summarize our entire journey together, let's look at this empirical evolution. We started with just a vague idea, and finally found our specific problem. Then we formulated a theoretical proposition. From there, we operationalized our variables to turn that proposition into a testable hypothesis. That hypothesis then dictates exactly what data collection we need to do. And finally, that hard data leads to the verification, or hey, sometimes the rejection, of our original idea. It's really just a beautiful, logical step-by-step evolution from a loose concept all the way to verified scientific fact.
Wow, we have covered a lot of ground today. You now know exactly how to cure problem blindness by seeking out those gaps in the literature. You know how to evaluate and formulate a rock-solid research problem, you can write smart objectives, and you know exactly how to turn a fuzzy theoretical proposition into a measurable, fully verifiable hypothesis. The framework is entirely in your hands now. So I'm going to leave you with this one question. You have your problem, your objectives, and your testable hypothesis. So what new knowledge are you going to uncover? Get out there and start investigating. Thanks so much for joining me for this explainer, and happy researching.